we're going to learn about how to calculate the concentration, which is a very important concept in chemistry. Okay, concentration and molarity, they are the same thing. We know many reactions occur in solution. A solution consists of one or more solutes dissolved in a solvent. The concentration of a solution is given by the quantity of solute present in a given quantity of solution. Molarity, given the symbol M, is often used to express concentration. How do we find the molarity? If you know the number of moles of the solute, you divide it by the volume in liters of the solution. So molarity equals moles over volume. Okay, so you have to remember this, and you will in fact remember this. Molarity equals moles over volume in liters. Okay, that's the molarity. It's so easy. So molarity given moles solute over volume in liters. Okay. Calculating the molarity of a solution. What is the molarity of an aqueous solution that contains 53.7 gram of glycine in 495 milliliters? Remember, molarity is given as moles over volume in liters. If you know the moles, if you know the volume, we can find out the molarity. And we know the volume 495. We can convert, but we need to convert it into liters. So we know how to convert milliliters to liters. You divide it by 1000, that would make it 0.495 liters. And how do you find the moles? We are given grams, right? So 53.7 grams of glycine. And if you know the molar mass of glycine, we can convert it to moles. So 1 mole glycine is the molar mass of glycine, which is, what is the molar mass of glycine? 75.07 grams. Grams to grams cancel, so we can find out the number of moles. That's going to be 0.715 moles glycine. If you are given grams, you convert to moles using the molar mass, and then you know the moles, and then the molarity equals moles over volume, and then the volume in liters 0.495. That would give us the molarity. It's 1.44 molarity. Easy, right? So that's how you calculate molarity. Same thing we did over there, converting to moles of glycine using the molar mass, and then converting milliliters to liters, and that gives us the molarity of the glycine solution. Okay. Calculating mass of solute in a given volume of solution. How many grams of solute are in 1.75 liters of 0.460 molar sodium hydrogen phosphate buffer solution? We also need to know how to write the formula for the sodium hydrogen phosphate. Okay. So, sodium hydrogen phosphate formula is Na2HPO4. We want to find out the grams. We are given the volume, we are also given the molarity. We know molarity equals moles over volume in liters. We are given molarity, we are also given volume. So then the number of moles are going to be M times volume, right? So the molarity is given to us as 0.460, and then the units for the molarity is moles per liters, and then the volume is given as 1.75 liters. So you multiply molarity times the volume. That will give you the number of moles. Okay, and that is 0.805 moles sodium hydrogen phosphate. And we want to find out the mass. So we know how to convert moles to mass using the molar mass of sodium hydrogen phosphate, like this. So using the volume and then the molarity, we found the number of moles, and then 1 mole sodium hydrogen phosphate is the molar mass of sodium hydrogen phosphate, which is 141.96. That gives us the grams or the mass of sodium hydrogen phosphate. What amount of each ion is in 35 milliliters of 0.84 molar zinc chloride? It's asking what amount of each ion. Now zinc chloride is an ionic compound. So we know zinc chloride is ZnCl2. It's going to form two ions, zinc ion 2 plus, and then chloride ions. How many chloride ions? Since there are two chloride ions. So we want to find out what is the amount of moles of each ion. So the types of ions we have is zinc ions and chloride ions. And we know from this dissociation equation, if you have 1 mole of zinc chloride, it will give us 1 mole of zinc and 2 moles of zinc chloride. So how do we find out the number of moles of zinc chloride? We are given the volume as 35 milliliters, and then we are given the molarity. Remember, molarity equals moles over volume in liters. So with the number of moles going to be molarity times the volume in liters. Molarity is given to us as 0.84 moles per liters. That's the proper unit for M. And then the volume is given as 35 milliliters. We can convert milliliters to liters. 10 to the power 3 milliliters equals 1 liter. Okay, liters to liters cancel, milliliters, milliliters. So we're going to have our answer in moles. So what's the number of moles going to be? That is going to be 2.9 into 10 to the negative 2. 2.9 into 10 to the negative 2 moles. That's the number of moles of zinc chloride. Now see, from our balanced equation, the dissociation, 1 mole of zinc chloride gives you 1 mole of zinc and 2 moles of chloride. So the zinc is going to be the same amount, and then the chloride would be double of this amount. Okay. This is what I just now did with you in the previous one, finding the number of moles of zinc chloride, and then the chloride would be the same amount, because if you have 10 to the negative 2 moles zinc chloride, in 1 mole you have 2 moles chloride. So it's going to be 2 times this amount, 5.8 into 10 to the negative 2, and zinc is going to be the same amount, since 1 mole of zinc chloride gives you 1 mole of zinc. Okay. Okay. Now, how do we prepare these molar solutions in the lab? This is how we normally prepare them. You take a volumetric flask because they are the most accurate. You will remember from your first experiment, which is measurement, that the volumetric flask gave you the most accurate 100 milliliters of water. Okay. They are expensive, so we use them if you want to make a solution of a correct molarity. Okay, first you put some water into your volumetric flask, and then you measure the amount of substance you want to make the molar solution. You put in here, and then with half amount of water, so without filling it up all the way to this mark, with half of water amount that you put initially, you're gonna dissolve your solid excuse me, completely with water. After all the solid is been completely dissolved, then you add water up to the 100 or 250 or whatever the mark that you want that has in this volumetric flask. What will happen if you just fill it up with some solid, undissolved solid inside the flask? After you put all the water up to the 100 milliliter mark, solid will start dissolving and then this volume will increase. So then we are not going to be getting the amount of volume that we desire to have. It would be very erroneous solution that we just made. So we want to make sure your solid is completely dissolved in half of the water excuse me, before you go ahead and fill it up all the way to the desired mark. Okay, that's how we normally prepare a molar solution in the lab. Now we will have some concentrated solutions and we need to know how we can convert them into a diluted solution. Mostly like the hydrochloric acid, the sulfuric acid, or any acid that you use in the lab, we get very high concentrations from the store, okay, from the vendor. But once they reach the lab techs convert them into a diluted solution or the desired concentration that is supposed to be doing for your experiment. So this is how a dilution works. Now this is a concentrated solution. You can see in this volume of liquid, it's more darker, meaning at a less volume of water, you have more solutes. Okay, we call it as a concentrated solution. More solute particles are present per unit volume and you add more water to that one. But we did not add any of these solute, you just add water. Now what happened to the color? Color is more lighter, meaning the same number of moles. We didn't change the number of moles. Same number of moles are now in a larger volume. Okay, we call it as a diluted solution. Same number of solute particles are present in the larger volume. So fewer solute particles are present per unit volume. So that is basically a diluted solution from a concentrated solution. It has the same number of moles, but it's going to be a different volume. As you can see, volume is different, volume is different. And then also the concentration is going to be different because concentration is moles over volume. Now let me introduce you something while we are talking about these diluted solutions. Let's say concentration of this solution is M1 and then let's say we have V1 amount of volume here, and then in your diluted solution you know that the volume had changed, right? It has more volume here, so that we can call as V2. Okay, now we know molarity equals moles over volume, correct? So volume here is V2. Now if the molarity equals moles over volume, it has the same number of moles. In your first solution and the second solution, you have the same number of moles, but you have now a different volume. So do you think now the molarity going to change? It's going to change, right? Because now we have a different volume. So we can consider this as M2. So this is going to be your new concentration M2. But both of them have the same number of moles, right? Because we didn't add any additional number of moles of the blue solute. So mole, so you can say first one, M1 equals moles over V1. And then for the second solution, concentration is number of moles over volume V2 because it's the same number of moles. Okay, so if you want to have an expression for this number of moles, that number of moles would be M1V1. How about this number of moles? That's mole going to be M2V2. But we know they have the same number of moles. So that is the origination of the dilution equation where M1V1 equals M2V2. That's the dilution equation. M1 is the concentration of one solution. V1 is the volume of the first solution. M2 is the concentration of the second solution. And V2 is the volume of the second solution. Since they have the same number of moles, we can say M1V1 equals M2V2. And we can use this equation to find out concentration or the volume of a diluted or a concentrated solution that involve a dilution. Okay. Preparing a dilute solution from a concentrated solution. Calcium chloride is used to melt ice. Okay, that's a little information. Calculate the molarity of solution prepared by diluting 165 milliliters of 0.688 molar calcium chloride to 925 milliliters. Okay, now do you understand? Now this is a dilution. We can use dilution equation here. Calculate the molarity of a solution prepared by diluting 165 milliliters. Let's say we have a graduated cylinder. Okay, we have a graduated cylinder, and then you have 165 milliliters. And then the molarity is 0.688 calcium chloride. You have this in a graduated cylinder. And then you're going to make a solution by diluting this amount to 925 milliliters. So this is 165 mark. Now you add more water to this one until it become 925 milliliters. Did we add any solute calcium chloride? No, you just add water. So what did we did? We just add water. So did the number of moles that you had in our original 165 milliliters changed? No, number of moles didn't change. Only the volume increased. Now it's asking what is the new molarity. So can we use M1V1 equals M2V2? Yes, we can. We can use this equation. So your M1 is going to be 0.688. V1 going to be your 165. M2 we don't know, and V2 going to be 925 because it has the same number of moles because we just add water, right? So you can use that. M1 V1, same number of moles. M2 V2. So M1, what's M1 going to be now? Let me find M1. Okay, so M1 going to be 0.688. 0.688 into 165, right? 165 milliliters equals M2 we don't know, and V2 925 milliliters. Now in a dilution equation, if you have the same type of units, you don't have to convert it to liters because the units going to cancel anyways. Okay, so the M2 then going to be 0.688. This is the molarity times 165 over 925. Okay, and this will give us the molarity of the solution, that is 925. Yeah, 0.688 clear 0.688 times 165 over 925, that's going to be 0.123 molar. That's how you use the dilution equation to find out the molarity of a solution, 0.123 molar. Okay. Okay, so I believe we can. The next one is about the precipitation reaction. Yeah, so we can stop here.